Alright gentlemen, we are back at it with Lab 4. On this one we are introduced to a powerful little tool in the camera. The camera has its own little window to show us what the robot sees from a first-person perspective, and we can program that camera to recognize specific colors or textures. All the tasks for Lab 4 are going to use the camera and some type of PID control logic to keep the robot at a desired distance, orientation, speed, or all of the above for one of these. The goal for all the tasks is going to be this large yellow cylinder with a texture that's able to be picked up easily from across the map. We can change the camera to detect whichever color we want, but we're only recognizing yellow objects for this one. In this case, that one yellow object is going to be the tall cylinder. That's going to be our goal. Now, for task 1, it's pretty simple. We're just going to be trying to face that goal at all times. Task 1 wants me to use the camera to detect a goal object and continually face the robot towards that object from any position on the map. To accomplish that, I use the camera's ability to chart exactly what position in the camera image the goal is at any given time. So when an object is recognized by the camera, there's like exactly 80 possibilities for where that object is on the camera's x-axis, meaning when x is 40, the object's centered on the camera. My robot spins in place until it detects yellow, and it'll either spin left if that x value is reading above 40, or it'll spin right if it's reading below, only stopping when the goal is like directly in the center of that little camera, which you'll be able to see in a second. I'm going to test it by moving the robot around the map, and the goal is stationary, so it should turn in that direction each time, or if it doesn't see it, it'll keep spinning. And then I'm going to move the goal around the map and try it that way as well. So this is the first-person view that the robot sees, and this is our robot. We got the front, right, and left sensors. This is our goal cylinder that we're looking for. Down here it'll constantly be printing the orientation that it shows in degrees, and it'll also print whether it sees a goal or not. So I'm going to go ahead and play it, and you'll see it spinning here, and now it sees yellow and it's centered. So down here you have the IMU reading in degrees and what the sensors are going for. So to play around with it, I'm going to slide the robot around, and it should just constantly face the yellow no matter where I put it. Just keep doing that for a little bit. Alright, so now I'm going to try just moving this thing around all over the place, and you can see that it's kind of following on that top left first person view. But if I'm right behind it, it should just keep spinning. So, looks like it works. Task 2 is pretty similar to the last one, but as you might expect, this one wants us to drive towards the goal, and we're going to be stopping 5 inches away. For this, I expanded on task 1 by adding a PID function to drive towards that desired distance of 5, and I kind of explained how PID works a bit in the last Lab 3 video, so I'll spare you for now, but just know that the way the PID is designed, the robot never actually stops at exactly 5 inches, but it wiggles back and forth very, very closely. Again, I'm gonna test this one by starting the robot at different locations, and then I'll try moving the goal so we can kind of see if the robot will follow it around. So we have this here, again with the sensors, front, right, left. It's gonna print the same thing with the orientation and the sensor readings. So here we go. Spins to face it, and it pushes towards that thing, and you'll see here in the middle that it should be pretty close to 5. I can actually move it forward and it should go back to 5 since it's 3. Yeah, see, you can kind of see it reverse when it's too close. That's how you know the PID is working correctly, because it's always trying to go exactly to 5 or close to it. But I'm going to restart that and start it at a different location. You can see it doing the same thing, driving all the way up, trying to get to 5. Move that again. And it never actually stops, so I should be able to move it while it's going, and it should still head towards it when it sees it. Alright, and then I'm gonna try it again, but this time wiggling around this thing here. So I'm gonna go ahead and start it, and you can see that when I move the cylinder, it's still trying to follow around and get exactly at that center axis and drive towards it. Once it stops at 5, I'll call it done, and we'll move on to the last one. There is a third task here that I've only partially completed, where we use the camera to implement the bug zero algorithm. The lab isn't actually due for another week, but I won't be around a PC this spring break, so I'll just have to show you what I have so far and where I'm stuck at the moment. But first, let me explain a little bit about the bug zero algorithm. So the way this one works is you beeline towards the goal whenever you aren't blocked by any obstacles, but in the case that you are, you just wall follow that obstacle around its edge, either left or right, until you have that ability to head straight towards the goal again. I mean, that's really it. This simplicity comes at a cost, because there are some situations where your robot will never quite reach the goal, which I'll show you in a second. But first, check out this image here. The obstacles in our way are these gray shapes, and the goal is highlighted yellow over here. You can see that the circle down here is our robot, and it's either always heading directly towards the goal, or it's wall following to the left. So this one is a success case where the robot will reach the goal, because it goes to goal, wall follows, and then here it can go to goal again, so it does. Then it wall follows, and then boom, motion to goal, you're good to go. That doesn't always happen, which down here you can see there's a fail case for the bug zero algorithm. When these algorithms fail, you kind of get stuck in these endless loops where the robot never reaches the goal. Here you can see that once it hit a wall, it went left to wall follow. It tried to go straight to the goal again, but it has to wall follow. And once it gets back, you can see that it would loop in this same pattern over and over and over again. But the smarter ones among you will probably notice that this one actually does work if they wall follow to the right instead of the left. So if they started here, it would wall follow right, and then once it could see the goal again, boom, motion to goal. It doesn't always work, as you can see, and you really have to decide either left or right at all times, but they do have a bug 1 and a bug 2 algorithm that kind of add some smart tweaks to this formula that'll make it reach the goal more often than not. I've got like an actual bug in my Task 4 controller that I've been trying to iron out. It's kind of breaking the wall following on specific corners. I tried both the left and the wall following right, and it kind of breaks at the same points here and here. It'll stop wall following. We call it motion to goal when we're driving straight towards the goal and there's no obstructions. And from what I can tell, the bug I have here is rather than switching from wall following to motion to goal, it's kind of stuck in a loop, wall following and then trying to detect the goal every once in a while. Right there, it just keeps going straight rather than following around. It does follow the outer wall for some reason, but I'm sure it's an easy fix. Haven't found it yet, but I'll let this one play for a minute.